What does an outflow boundary look like on radar reflectivity? Have you ever wondered what happens when a thunderstorm releases its cold air? This phenomenon creates what we call an outflow boundary, also known as a gust front. It's fascinating how this small-scale boundary can be seen on radar. So, what does it actually look like? On radar reflectivity, an outflow boundary appears as a thin, linear feature. You might notice it as a faint line or arc that moves away from the thunderstorm itself. This line indicates the leading edge of cooler, denser air that spreads out near the surface. What's interesting is that the radar reflectivity values associated with outflow boundaries are usually lower than what you would see with heavy rain or hail. Typically, these values fall below 30 decibels of reflectivity. The radar is picking up on small particles like insects, dust, or debris that get lifted by the gust front, rather than raindrops. Sometimes, you might see a shelf cloud accompanying the outflow boundary. This can also be detected visually and may show up on radar as a distinct feature. As you watch radar loops, you can see these boundaries spreading out from the storm in various directions. They might even encircle the storm or move ahead of it. For those involved in high-risk weather professions, recognizing outflow boundaries on radar is essential. These boundaries can act as focus points for new thunderstorm development. They create areas where winds converge and lift air parcels, which can trigger new storms. Understanding how to identify these features helps storm chasers anticipate storm behavior. It also aids in avoiding dangerous wind shear or sudden gusts that are often associated with the boundary. So, when you look at radar reflectivity, remember that an outflow boundary looks like a thin, faint line or arc of low to moderate reflectivity values. This line extends outward from a thunderstorm, primarily caused by airborne particles concentrated along the boundary. This visual cue is vital for anyone chasing storms or working in extreme weather environments to predict storm evolution and hazards.